A passive house is designed, fabric first is the principle they say. You get the building fabric right, and then you make sure that the penetrations, so the electrical cables, telephone wires, satellite TV, water coming in, waste pipes going out, are all well sealed back to the fabric. In this case, mostly to wet plaster on blockwork walls, which is the main airtightness in these properties. So the idea of the Airtightness Champion process is that Mike and Robbie basically prove that the fabric is okay before they start putting penetrations through. That's the theory. Of course, the problem is that the program on site, the desire to always get ahead, means that doesn't happen. You know, so people start installing plumbing, and we actually have had test fails on this site because of that kind of thing. But what's still true is that the basic fabric is working well. So this is a small calibrated fan. It's made in the States. And we like the small fans because otherwise we find we can't get low enough pressures to do proper testing. The standard, the UK standard, and the Passivhaus Institute set a maximum of 100 pascals because of concern about damage to plasterboard and the like. So we've hung this nice and easy on a screw, and I'm just going to go outside and tape it up because I have to get a good seal between here and here, and that's much easier on the outside. This red tube is where we measure the pressure difference from inside to outside, which is of course one of the key variables in the test. The other one being the airflow, the amount of air we are blowing through the fan. This is the other end of the pressure measurement, so we don't want that too close to the fan because that gives us inaccurate readings. But also we want it visible, so there's no no joker on site blowing in the end, which has been known to happen. So we stick it on the outside of the door so we can see the end. So this is our digital gauge for measuring the pressure difference inside to outside and the airflow through the fan. And it also actually controls the speed of the fan. So you can see you've got the red tube running around through this piece of wood to outside. So that's measuring the difference. And the yellow tube measuring the pressure in the fan, which tells us the airflow. And this way round, the fan is blowing out. So the house will be at a lower pressure than outside. We call it a depressurization test. And it's normally the test we do first because when we have a low pressure inside, just atmospheric pressure forces air back in through any gaps. So we suddenly can very easily find if a door's not properly shut, a window, there was water in a toilet trap or something like that, or under a sink. Because this is an acceptance test. This house is almost complete, certainly complete enough in passive house terms for the Institute, for the certifying bodies to accept it, and the airtightness is one of those parts of that acceptance. On this site, we're doing one preliminary test, providing it gets a satisfactory answer. So we're basically ready to go, I think, aren't we? Okay. All right. The principle of locking the door means no one can come in and mess up our test. So our target test pressure, we have to get at least one reading above 50 pascals. Now 50 pascals is not a big pressure. It's the same as 5 millimeters of water column. And 50 pascals doesn't hurt budgerigars or people or anything like that. So we're comfortably up at 80 pascals, and this is only running at 10% speed, so that's a good sign. So this is showing a flow rate of 65 cubic meters per hour, and these have a volume of about 180, so that's a reading of about 0.3. right? And the target is to be below 0.6. So that's quite comfortable. Nevertheless, we start off by going around and checking, making sure all the windows and doors are properly shut, there's water in the traps. Okay, do you want to do upstairs, Robbie?
Yeah.
I can feel air on this keyhole. If I took the key out, it's much more air. You can really feel it. So everybody who's doing passive house testers, the contractors will always leave the keys in the door. This is the heat recovery unit. So basically it's open to outside. It has an intake filter here and an exhaust filter here. So you can see we've taped them over and sealed it up to stop air coming through this unit. I mean, the fundamental airtightness is plaster on blockwork here. That's most of the airtightness in the whole of this project. And obviously, here, you've got chasing into the blockwork to allow the socket box and then the socket to be fitted. So what we've ensured, where it's been chased out, has been parged over before the socket boxes and the sockets were installed. And that applies to whatever these are, TV, light switches, light boxes, anything. So this is basically taking a series of readings of airflow against pressure for different speeds of the fan and then putting it in the software. And the other thing is we have to take 20-second averages, time averages on the readings. So any little fluctuations due to wind or anything else go away. We're going to turn the fan around in the window and we're going to blow air in, pressurization test, which is the second part of the passive house. There are elements of the house that will be the same, whether you're pressurized or depressurized, mostly the plaster. Then there will be things that will vary. Possibly the heat exchanger might be slightly different, whether it's pressurized or depressurized. Upstairs, where there's membrane that's providing the air seal, if the membrane's pressurized, it's forced against the OSB timber that's behind it, so it tends to seal better. So we commonly expect to get slightly better pressurizing, but not always. You know, the windows and doors, generally, they may seal better, or they may seal worse. Even though you think you're pushing them shut, you may actually displace the seals. But, you know, on any house, depending on the wind direction, if the wind blows this way, across the valley, you probably get pressurized here, trying to force air in. Then it goes over the ridge of the house, and there's a suction on the other side, trying to suck air out. So the idea of pressurizing and depressurizing and averages, because the average is what you get in normal life. .40 average.
That's so far.
The target is an air change rate of 0.6, right, which compares with the building regulations of 10, so it's 15 times more onerous than building regulations. And this is just achieved 0.4, so it has a little bit of a margin, which is where you want to be, because chances are it will get a little bit worse over the first year or two, drying out, cracking, wear and tear, possibly people putting in things like external security lights, things like that. But yeah, it's a good result.